Hi, welcome to micro lesson A2A.3. In this lesson, we will determine reasonable domain and range of a linear function given a verbal description. Number 1 says the business club opened a lemonade stand and sold cups of fresh lemonade in the cafeteria during lunch on Monday. The profit earned is a function of the number of cups of lemonade sold. The function consists of only the ordered pairs 0, -8, 1, -4, 2, 0, 3, 4, 4, 8, and 5, 12. What are the domain and range of this situation? When we are given a list of coordinates as our domain and range, that means that our data is discrete, which means these are just going to be coordinates. And so our domain, when we have a list of coordinates, our domain consists of these x values for each set of our coordinates. So I'm just going to underline those in blue for you. And so when we write it out as a domain, we're just going to do it as a list. And we're going to remember you go from least to greatest when you do a list. And if a number occurs more than one time, I only list it once in my domain. So if you're working on a multiple choice test, just be mindful of that if a number comes up more than once, then it will only be included in the domain or range once, even if it occurs more than twice. And then our range will just be our list of all of our y values for this particular scenario. And those are -8, -4, 0, 4, 8, and 12. And so again, we're going to list them from least to greatest so they don't have to match up with the x value. So we're just going to write them. These happen to match up, but they don't have to, so don't think that they always will. And -4, 0, 4, 8, and 12. So if they give me a list of coordinates for a function, then I can find the domain and range without having to find the equation. For our next one, it says a community swimming pool that contains 45,000 gallons of water is being drained for the winter. The amount of water remaining in the pool G is a function of the number of hours H it has been draining. The pool is draining at a rate of 1,500 gallons per hour. What are the domain and range of this function, or for this situation? Now, it's gallons of water and it's in a swimming pool. So I'm starting big and I'm going to be getting small. I also know that eventually my pool is not going to have any water left in it. So that I know that 0 is going to be a boundary of my range because I'm starting with 45,000 gallons and eventually here I'm going to get to 0 gallons of water. Okay, so this y-intercept and this point down here where I land on 0 on the x-axis from 45,000 to 0 is my range. And I'm going to write this as an inequality statement because both my x and my y-axis are measurable in this scenario, which means there's half parts are partials. And so I can measure the water continuously, and time also is continuous. So the range, or my y values, start at the smallest at 0, when the pool is completely emptied, all the way up to the top boundary of 45,000 gallons because that's the total amount that the pool will hold. Now let's talk about our range. Our domain. I usually do the domain first, so that kind of threw me, but we're going to do, we did the range first because it was a little bit easier. So now I know that we're talking about time in hours, and I start at 0 right here. So I know that my domain has a 0 boundary on the left, and x is going to be somewhere in between this. But I'm looking for this number right here. because that's going to be the end point of my function. So I have a line that's going to look something like this. So I need to find out, what number is that? Well, that's the number of hours when the pool is completely drained. And so for this one, I am going to have to create a little situation and mathematically solve for that number. And so I know that there are 45,000 gallons in my pool, and I'm taking them out at a rate of 1,500 gallons for every hour. And I want to solve this for when I have no water left in my tank, which would be 0. And so I'm going to subtract my 45,000 on both sides, which means negative 1,500 H is equal to negative 45,000. I'm just moving it over to the other side. And then I'm going to divide this by negative 1,500. And so it takes 30 hours for the pool to drain. And so this number right here would be 30. And that would be the top boundary, or the right side boundary of my domain. And I'm going to put in my continuous inequality signs. And so this is how this works. So here on our range goes from 0 to 45,000. And then here for our domain, we go from 0 to 30. And we had to solve for just that one number. So it is important that you understand the scenario and are able to come up with the equation, because in some circumstances you're going to have to solve. But if we think of in terms of a multiple choice question, we know this number is always going to be positive, and that it would be a reasonable number. So if I had a multiple choice array of answer choices, I would know that I was looking for a number that was positive, and that wasn't an outrageously huge number like we started with.